Now, the idea of $1.99 biofuel is not a far-fetched notion, but whether it's biofuel or something else, many scientists believe it will be found right here in the Bay Area. ABC 7's Laura Anthony takes us to Emeryville, and a lab that many expect will find the answer.
Every day, hundreds of thousands of cars crowd Bay Area streets and highways. For every gallon of gas burned, nearly 20 pounds of carbon dioxide is released into the environment, the biggest contributor to global warming. But inside this Emeryville lab, researchers are applying for answers to America's fossil fuel dependency. This is a Joint Bioenergy Lab Institute, or JBEI for short.
I think JBEI has a real chance of addressing and solving some of these huge problems.
The lab opened in March and is funded by a 5-year, $134 million grant from the Department of Energy. The project has one primary goal: turn agricultural waste into fuel.
We have roughly 1.3 billion tons of biomass every year that's just lying in fields, lying in landfills that we're not doing anything with. And we have this huge potential. And if you look at the energy in that mass of waste material, it's roughly equivalent to the energy that we import every year as petroleum. But we have to convert it.
The goal of JBEI is to achieve measurable success within the next 5 years.
There is a sense of urgency. We've got a real national need.
JBEI is made up of 6 partner institutions led by the Lawrence Berkeley Lab. The group also includes UC campuses at Berkeley and Davis, the Lawrence Livermore and Sandia National Laboratories, and the Carnegie Institution of Science.
Let's not kid ourselves. The ultimate goal here is to mitigate the greenhouse gas emissions derived from fossil fuels, as well as to decrease our dependence on foreign oil.
Blake Simmons leads a team of scientists at Sandia National Lab in Livermore for JBEI. They are scavenging the environment for naturally occurring enzymes best suited to break down biomass into fuel.
We're doing a lot of fundamental research into looking at advanced enzymes and advanced organisms that can more efficiently assist in the degradation of biomass into biofuels.
Enzyme engineering as a task is basically trying to improve the characteristics of enzymes so that they're most suitable to what you want to do.
Finding the one that best turns agricultural waste into fuel hasn't happened yet, but the scientists associated with JBEI are convinced it's out there. But don't expect the gas at the pump to be replaced in the next couple of years. Whatever's developed here tomorrow likely won't be widely seen until far off in the future.
We have the opportunity to do research that will lead to transportation fuels that you can put in your automobile today, that we can put into jet engines, that we can use to power our economy going forward into our children's and grandchildren's generations.
In Emeryville, Laura Anthony, ABC 7 News.
The Bay Area obviously is no stranger to renewable energy. We've been out in front many ways for many years. The Altamont Pass wind farm is one of the oldest, but the turbines are nearly obsolete now. UC Davis researchers are looking for safer and more efficient ways to capture the wind's energy. More on that now from ABC 7's Eric Thomas.
They are giants that rise from the hills in Solano County, some of the world's largest and most advanced wind turbines. As they spin, each produces enough energy to power as many as 1,500 homes for an hour. They are good, but to Dr. Kees van Dam, they can be better.
Right now, wind energy only in California, it only represents a small percentage of the total electric power.
Van Dam runs the California Wind Energy Collaborative, the place for wind energy research in California.
That is an effort that was started in 2002 with the focus of really working closely with the California Energy Commission and the industry, the wind energy industry in the state, to work on issues facing wind energy in California.
The collaborative's goal is simple: make wind energy safer, more reliable, affordable, and environmentally sound without endangering birds. It's not a new idea. At one point, California accounted for 99% of the world's wind power production. Today, Texas and Europe surpassed the state in wind power production.
We understood, I think, what wind energy could do for us in California in the 1980s, 70s, and 80s, and then we lost interest.
Today, much of that era's wind power tops the hillsides along the Altamont Pass in eastern Alameda County.
When you see Altamont today, I call it a living museum. It is really wind energy in the 1980s.
The modern wind turbines in Solano County produce a lot more energy.
One of the wind turbines in Solano replaces about 15 to 20 of these small wind turbines that you see in Altamont.
The Wind Energy Collaborative is working on the next generation of turbines. Carefully crafted models are built here and blasted in wind tunnels to explore the best places to put wind turbines.
You can get a year's worth of wind data in a matter of weeks to months.
A couple years ago, when the windswept hills near Candlestick Park were eyed for wind turbines, it was the Wind Collaborative that tested out the coastal breezes. The site was good. However, the plan for turbines has been shelved. But natural landscapes aren't the only ones that may provide ideal conditions for wind power generation. Man-made landmarks are also being explored for their wind power potential.
The purpose that we did this study was to assess the resource of wind that we could potentially harness energy from.
It's one thing to know there is wind, but how do you best capture that power? That's what aeronautical engineers are doing with this prototype turbine blade. Those threads measure the wind direction to maximize power generation on this blade.
If the model is in this orientation, this would be a positive angle of attack. This is a negative angle of attack.
The more positive angle of attack, the more the blade will spin. The more the blade spins, the more electricity generated. Computer modeling can replicate many of the same conditions found in nature, giving wind researchers another tool to test out new theories.
In the past, people have used sort of more rudimentary and simple computer models to design these turbines.
Researchers have access to some of the most sophisticated tools on Earth, including software originally developed for NASA to design the next space shuttle.
We believe using modern tools, we can improve that performance and the efficiency of these devices by quite a bit.
We're looking at the coming 5 to 6 years, 4,000 additional megawatts coming online.
That's enough energy to power 3 million homes. Eric Thomas, ABC 7 News.
One of the many issues the California Wind Collaborative is working on is how to manage the intermittency of wind power. Like solar power, it doesn't always generate electricity, so a strategy needs to be developed to keep too much or too little power off the power grid.
We move now from wind to the tremendous potential of the waves and tides to produce energy. ABC 7's Carolyn Tyler reports.
Normally, mixing water and electricity doesn't seem like a good idea, but new technology using the power of the ocean is making waves in the power industry.
We're talking about locating generators that would be about 9 miles off the shore.
But San Francisco's Public Utilities Commission is looking in the bay and off California's coast to make electricity.
It's measuring the wave motion so that we can then take that data and calculate what the generation potential is by the movement of those waves.
Specially designed buoys bob with the ocean waves, undulating with the water or moving snake-like up and down. The movement generates energy that can be captured and sent back to land.
What's wonderful about waves is it's a vast resource. There's lots of potential. What we're looking at is it going to work here in San Francisco?
This isn't the first time the city has looked at its surrounding waters for power. In 2006, the city proposed using the natural tidal action of the bay to spin windmill-like turbines to generate power under the Golden Gate. And in 2007, the city and PG&E penned an agreement with Golden Gate Energy to further study the potential for generating power. This company video shows how another type of tidal power generator could work. But a study by the Electric Power Research Institute raised questions about the feasibility of such projects. Not only would it cost too much to build and maintain them, but according to the study, it would only generate a small amount of power. Offshore power generators, on the other hand, are already used in Europe and produce power for tens of thousands of homes. And it may be coming to the North Coast soon. This video provided by PG&E shows the type of devices they may use off the coast of Fort Bragg and Eureka.
It's important that we work with the local community, the environmental interests, the recreational interests, as well as the commerce interests, to assess what the potential impact is of the technology.
The power of the ocean.
This company animation shows an ocean power plant. If built, the two projects will generate enough power for 45,000 homes.
Wave and tidal represent two of the more innovative technologies that hold immense promise.
Power generators are confident the ocean holds at least some of the answers to our energy woes.
All of us as a society, as utility executives, are looking at ways to generate electricity that address our climate change concerns, and wave generation is absolutely one of those technologies.
Carolyn Tyler, ABC 7 News.